So where are we here?
So we are at Cranfield University, which is in the UK. Cranfield University is quite unusual in the UK in that it is postgraduate only and very much focused on engineering. So my role within the space group at Cranfield, and I joined that I guess about 7 or 8 years ago, from a non-space background. So my original training was in the biosciences and worked for many years, including at Cranfield, in the medical diagnostic, environmental diagnostic sector, and then almost accidentally got involved into space in proposing a instrument or a sensor that could potentially go to Mars to search for evidence of life. So that got me into the space sector, and then I joined the space group here at Cranfield, as I said, a few years ago. And so my role within this group now is to look at space systems engineering, as most of my colleagues do, but with a special focus on those systems which involve some kind of biology, the biology for experimentation, biology to support human activities, or of course the biology of humans themselves in space.
Could you summarize your contribution and your interest in the SpaceBorn United project?
Yeah. So with the kind of interaction with SpaceBorn United, that kicked off a few years ago. And we got involved in that we were already doing space systems engineering consideration of biological experiments and demonstrations we could fly in space. And so what SpaceBorn United was considering was clearly related to that. And so we initially got involved with doing some very general concept studies about mission designs and payloads. In fact, using a resource here we have at Cranfield, which is our master's students. We have an MSc course or master's level training course in astronautics space engineering. And therefore we have a large number of students, early career stage students in the space sector that are interested in projects. And so we use some of those to help advance some of the very early stages of concepts with SpaceBorn United. And we've had a number of those projects, both at group level and individual student level, that's developed a relationship so that we are now one of the collaborators involved in the ARTIS mission concept and helping to advance the understanding and the status of that mission. So if we now look in a bit more detail at some of the specific bits of the mission ARTIS that we're considering, especially going forward over the next year or so. The kind of things we're looking at are things like how do we implement the cryogenic storage of the embryos, so that once the embryos are formed, how do we then preserve them in a way similar, or in fact ideally identical to what happens in a typical IVF clinic on Earth? How can we do that in the spacecraft and mission context, and therefore preserve those embryos all the way back to the landing site, and so those embryos are then transferred over, still cryogenically stored, to the ground support. And so we're at the early stages of considering some of the design issues and associated with that cryogenic storage. Because of our history with medical devices and microfluidics, we're not necessarily leading, but we're certainly contributing some of our knowledge to the development of the fluidics aspects of trying to implement an automated version of IVF within the mission, within the spacecraft context. And also still carrying on with the big space systems view of the overall mission design, which includes trying to understand and refine what is actually the main drivers of the mission design. And one of the things that we've already identified is the need to get regulatory approval as one of the key goals for mission ARTIS, to do IVF from a suitable regulatory body on Earth. And to achieve that and to minimise the burden of trying to get that, we've realised that really drives all kinds of design considerations in terms of the mission, to try and make the IVF that would occur in Mission ARTIS to look identical to what would happen on Earth, so that it simplifies the ability to get regulatory approval. So there are three kind of examples of some of the things which we're looking to contribute to going forwards to the development of Mission ARTIS. And there's one other kind of key area that we're considering, again within the context of the overall kind of mission concept, mission design, and that is, again, to help develop and demonstrate the technology. It's almost certain that we wouldn't do a first demonstration with human cells, human embryos, and therefore in the development phase we would be looking to use various animal models which are much easier to get regulatory approval, and would in fact be part of the kind of plan to get ultimately regulatory approval for human use, which is to demonstrate that in other mammalian systems that we can implement kind of IVF in the Mission ARTIS kind of format. If we can demonstrate that successfully, then that again contributes to building the case that would eventually go to the regulatory authorities to then try and get regulatory approval for actual human use.